let's take a look at an equation like this. Cosine of 3x equals 1/2. Right? So we want to do something very, very similar to what we've been doing. Right? In an equation like this, the first thing I would want to do is get the trig function by itself. That's already done for me. Okay? Cosine is already by itself. So I can now go to the unit circle and see where cosine equals 1/2. Where does cosine equal 1/2? Pi over 3. 5 pi over 3. So, just like we did before, we're going to take whatever's on the inside of the trig function and set that equal to these angles. So I'm going to say 3x equals pi over 3 and 3x equals 5 pi over 3. Now, the difference from what we did before, I need to tack on my plus 2 pi n for solving here. Okay? Because if I'm looking at a triple angle, when I divide, I'm going to divide both of these things by 3. Before, what we looked at was something, we had like cosine of x minus pi over 4 equals 1/2, right? Something like that. We said, well, we're going to take x minus pi over 4 and set that equal to pi over 3. Solve, and then tack on the plus 2 pi n. But really, we could have had the plus 2 pi n in there in the first place. When we add pi over 4 terms, the only thing I would add the pi over 4 to would be the pi over 3. In this situation, if I'm dividing both sides by 3, I need to divide everything by 3. Okay? So, if I divide everything by 3 over here, we'll end up with x equals pi over 9 plus 2 pi n over 3. Just dividing both these things by 3. Same thing over here. Divide both of these things by 3. And we will get x equals 5 pi over 9 plus 2 pi n over 3. So if the question asks us for all solutions, that'd be it. We'd be done. But this one just wants all answers in the interval 0 to 2 pi. So, what we need to do in a situation like that is figure out how many of these are going to occur in between 0 and 2 pi. Right? Since I'm not going every 2 pi, I'm just going every 2 pi over 3, there's going to be multiple times where this solution set is going to occur in between 0 and 2 pi. Same thing over here. So, if we start by plugging in and remember, n is any integer, not just whole numbers. So n can be any integer. So if I plug in -1, right, we have pi over 9 plus 2 pi times -1 over 3. Or pi over 9 minus 2 pi over 3. Right? So you can use a calculator to do the fractions if you want. Right? If you do it by hand, this would end up being pi over 9 minus 6 pi over 9. So that would end up being -5 pi over 9. Which is not in between 0 and 2 pi. Right? So, -1 would not get us an answer. This would not be an accurate result. Right? But we want to start with a negative value whenever we're plugging these in, just to get a base. And we're going to start plugging in values greater than that. Right? So we would want to do the same thing over here. We want to plug in -1. 5 pi over 9 plus 2 pi pi times negative 1 over 3. Right. And again, if we make this 6 pi over 9, or negative 6 pi over 9, 5 pi over 9 minus 6 pi over 9 would be negative pi over 9. Again, negative pi over 9 is not in between 0 and 2 pi. Okay, so that's not a solution. So now, let's plug in 0. Okay, I guess we can label here, this is n equals negative 1. Plug in n equals 0. So we'll get pi over 9 plus 0. Okay. So pi over 9 is in between 0 and 2 pi. That's one of my solutions. Do the same thing for this solution set. So x equals 5 pi over 9 plus 2 pi times 0 over 3. So 5 pi over 9 is a solution. Okay, so we get two answers so far that are in between 0 and 2 pi. Let's check n equals 1 now. So if I plug 1 in for n, I'll have pi over 9 plus 2 pi times 1 over 3. So, again, getting common denominators, this would be 6 pi over 9. So 1 pi over 9 plus 6 pi over 9 would be 7 pi over 9. That is in between 0 and 2 pi. So that's another answer. And do the same thing over here. Plug in 1. So 5 pi over 9 plus 2 pi times 1 over 3. So again, that's 6 pi over 9. So 5 pi over 9 plus 6 pi over 9 would be 11 pi over 9. That is still in between 0 and 2 pi. What if we're thinking about a denominator of 9, what's the greatest that my numerator could be?
12.
18, right?
Oh, it's over now. I'm stupid. Sorry.
Yeah, over 9. So we're looking for any values that are still less than 18 pi over 9. So let's keep going. Let's plug in n equals 2. So pi over 9 plus 2 pi times 2 over 3. So 4 pi over 3, again, changing that to a denominator of 9 would be 12 pi over 3. Or, I'm sorry, 12 pi over 9. So 1 pi over 9 plus 12 pi over 9 would be 13 pi over 9. That's still between 0 and 2 pi, so that's another answer. Same thing over here. 5 pi over 9 plus 2 pi times 2 over 3. So 4 pi over 3 is 12 pi over 9. So 5 pi over 9 plus 12 pi over 9 would be 17 pi over 9. And that is still in my range. So let's try n equals 3. So pi over 9 plus 2 pi times 3 over 3. So 6 pi over 3 is 2 pi, right? So if I take pi over 9 plus 18 pi over 9, that's going to be 19 pi over 9, and that is outside of my range finally, right? Because we said 18 pi over 9 is 2 pi, right? Obviously then, if we take 5 pi over 9 plus 2 pi, that will also be outside the range. So for this problem, we end up with 6 answers. Okay, my solution set would be pi over 9, 5 pi over 9, 7 pi over 9, 11 pi over 9, 13 pi over 9, and 17 pi over 9.
Is there any way we can get like maybe one of these at most in the test?
Yeah, on the test, something like this certainly takes a little chunk of time. So it's useless. Yeah, you're never going to have to do this in your life. That's not what math is for.
Well, shouldn't it be about that though?
So, no. I don't care if you remember how to do this in 5 years. What I care about is that the process of math, learning something and applying it to a new situation, literally increases your intelligence. Like they can pinpoint how the new neurological pathways are created in your brain when that happens.
What if I want to be stupid?
Take that.
Can I go to the restroom?
Sure.
Are we just gonna do an example problem now, like our own?
Yeah. All right. So, questions.
You're gonna have a kid eventually.
Yeah.
That is the goal.
All right. Why don't you guys try one then? How about two sine of 2x equals square root of 3. Okay. Find me all the solutions to 2 sine of 2x equals the square root of 3 in the interval 0 to 2 pi.
See, I just don't know how to set it up. I know how to do the rest of it. But what do you do about the 2x? What about the 2 out front?
Divide both sides by 2.
And then divide it by 2 again? Oh my god.
So this would really, if we divide by 2, we'll have sine of 2x equals square root of 3 over 2. Okay? So now, go to the unit circle, find where sine equals square root of 3 over 2.
Oh, and then you put that over 2.
Right, so then we'll say 2x equals that plus 2 pi n, and then divide everything by 2.
Yeah. So can you do that like all the way up in like, where is it, like 40, like 3 cosine of 40?
Yeah.
And if it was just like 3.
No, you can do that for any multiple of an angle here, yeah. So, so probably
Did you get like 5 of
that
that?
one.
But you said 2 pi, right?
Yeah, in between 0 and 2 pi.
You don't do that. So like a fraction divided by 3, then you just multiply it by 1/3, right?
Yeah, dividing by 3 is multiplying by 1/3.
So it's really just going to be 2 pi over 9. Yeah. Because that's what it's like. And then multiply that by 1/3.
Well, in this case, it's going to be 1/2 because we're doing 2x here. We did 3x in the example.
Oh, I was reading my bad. So this is going to be 1/6. Yeah. Okay. But I was doing the right thing. I was just reading cosines. Thank you. Oh, and the pi cancels.
The 2's.
Yeah.
Yeah.
plus pi.
pi n.
You just killed it. Wait, I thought we didn't add the n.
No, we do.
It is true.
Alright, so where does sine square root 3 over 2 pi over 3 and 2 pi over 3?
Yes.
3 plus pi n.
You don't actually do anything.
Well, so if we just were asked
Oh, that's
for,
where you plug in the number.
right, that's where you plug in the number.
Oh. So it's just going to be 2 pi over 6 plus pi.
Or 2 pi over 6 would
Yeah.
reduce 2 pi over 3. So yeah, if we were just asked for all solutions, we're done. This is the answer. But if we want just the solutions in between 0 and 2 pi, then we have to start checking.
You didn't specify that in this question.
I did. I said that. Alright, so
yeah.
I said in between 0 and 2 pi.
Are you gonna give us one where it doesn't say that? Just like a little joke.
Yeah, you should do that on the test so that everybody
Well, I mean, you
Stop
you
yelling.
gotta read the question. Yeah.
you totally
You should be
need to do
sorry.
that now.
Hey,
You should be sorry.
He literally just looks at it.
That's not good.
Well, I've been sick for like
Mr. Fash, this is the only notebook that I've actually completely filled up. Because of your class.
doing math.
Your class.
So I mean, if it's a negative, it's not true.
Yeah.
But in this case, because it's 0 and 2 pi.
Right.
Would the interval ever change? Or is it always going to
What?
be 0 and 2 pi?
For our purposes, it will always be 0
I'm
and 2
sorry.
pi.
I know. You're just going to switch it up.
I,
2 pi.
I don't know. I don't know what to do to help you. Let's see. Can we get like maybe 2 problems on the homework at most?
It just took me 4 minutes.
I feel like it's gonna take me a lot longer. Not gonna lie.
Alright, so we should get for our solution sets up here pi over 6 plus pi n, pi over 3 plus pi n, so that if I start plugging in integers for n, we find 4 solutions in between 0 and 2 pi. Pi over 6, pi over 3, 7 pi over 6, and 4 pi over 3. Okay. Questions?
Sure.
Alright, then let's try
So
a couple of these.
Very serious. Yeah.
Maybe.
Look at my face. What's the face you made? Shut up. Yeah,
This.
you did this one.
No.
Guess what?
Three problems.